If you know the formula sheet at the front of your exam, and this question is not hard, but if you're not aware of what you're given, then this will prove quite a tricky question. Okay, so first thing we've got to do is write down what do we actually know. Well, as soon as I talk about curved surface area, we need to start thinking about what's the formula for that, which is given to us. Pi r L. Now, what do they represent? So here's my little cone. Okay. Clearly, this is going to be the radius, r. This is going to be the slant height, l. And the perpendicular height is going to be h. Because it's perpendicular, I'm going to draw a little right angle there. Okay, so let's have a go. Okay, so we're given the height, 25. We're also talking about the volume, and again, this is another formula that they give you in the exam. The volume of a cone is a third pi r squared h. And we've got h. We also told the exact volume, 1600 centimeters cubed. Everything's in the same units, so it looks like we can just go and work out the value of r. So if I times both sides by 3, divide by 25, I'm going to get pi r squared, divide by pi, and square root, and I'll get the radius, aren't I? Okay. So, of course I could be writing this all down, perhaps I should be, but it's easy enough to see what we're trying to explain to the examiner what we're trying to do. I'm trying to find the radius. Okay, and I think the radius is 7.82. I'll get to 2 decimal places, but of course I'm going to keep these numbers exact as I can in my memory of my calculator. So I'll put that into memory A, and I can use that later on. I need to know that slant height, don't I? But fortunately I can see that I've got an H and I've got an R, and this is a right angled triangle. I know it's a triangle that's standing up, right? It's a three-dimensional triangle, but it's still a triangle nonetheless. So L squared is equal to R squared plus H squared by Pythagoras. So L, well, if I just found the radius, so I can square that, can't I? And I know that the height is 25 squared, and if I square root that, I'm going to get an exact value for the slant height, which is 26.2 to 1 decimal place, or 2 decimal places, that's fine. And also I'm going to put that into my memory B. Okay, so store memory B, or if you've got the older calculator, the shift store memory B. Okay, so now I've got all my letters sorted out. I've got my R, H and L. I'm going to write down what I know. So when they've laid out the sort of net for this cone, you can see the slant height is the sides, the parallel, which are the same length. And I can use the formula pi RL to work out the area of this sector of a circle. So pi times by R times by L gives me 643.42. Okay. Again, if I use my memory values, I can put down a much more exact answer, but I think this is okay because we're only asked to give it to the nearest whole number. So I think I'm okay to round up to 2 decimal places. Right, so now let's just think what we've got. We've got part of a circle, haven't we? And that's what we're looking for. And we can find the area of that whole circle, which is pi r squared. Well, we've got the radius, it's 26.19. It's not the same as little r, this is the slant length, isn't it? Squared times by pi, that's the area of the whole circle, timesing it by the fraction of the circle that I've got. I've got x out of 360 of the circle. And we're told that we know, we just worked out this area that we've got is 643.42. So that's enough to solve for x. So if I do 643.42 divided by pi divided by 26.19 squared and multiplied by 360, I should get to my value of x. Okay. Good. Okay. So now I've got that. I reckon it's 107 to the nearest whole number, so I have answered their question, and I think that will do. Now let's look at the marks and see how we did. Oh yeah, of course, the exams report first. Do pause these; they're very worthwhile reading. A lot of blank script. It says, gosh. Okay. And 107 degrees. Good. Excellent. Okay, it looks like they were keeping 3 sig figs as they're going through, or maybe they were using exact values stored in their calculated memories.